So I've got good news to start with, which is I've got a white background, okay? So everything's going to be absolutely fine. Hands up who knows everything about CCA Realms. Okay, I'm off. No. Okay, so we're going to be talking about that, but more broadly. So firstly, there's a problem, right? And that's it. I just do not trust you at all. And but to be fair, you certainly shouldn't trust me either, or in fact, anybody else. And this is the world we live in, right? When we're doing security stuff, and this is what happens. This is what happens. You've got to have a picture of a cat. This is the picture of the cat that you're going to get today. There may be more, but you've got one. So let's think about the problem in terms of what we talk about, which is systems, right? And this is kind of how I think of computers these days, right? You've got a sort of gray box. You've got a host operating system, and you've got some workloads. And the green workload is my workload, the workload I care about, the workload you care about. Okay, so that's what we want to protect. And there's a number of things that can go wrong. The first thing is, other workloads can be bad, right? They can try and get into, mess around with your workload, interfere with it. That's a bad thing. We don't like that. But we can kind of deal with that most of the time, right? We have virtualization, containers, a whole bunch of other really nice controls. This is where things get really difficult, right? If the host itself is malicious or compromised, whether it's the kernel level, the administrator level, hypervisor level, whatever, you've got real problems. And virtualization ain't going to help you. It's not what virtualization helps about. So, hurrah, confidential computing. So let me just briefly go through a definition of what confidential computing is. So it is the protection of data. First thing, we care about data, right? So we're going to protect it. In use. Okay, so this isn't just when it's in transit on the network, in storage, on disks or whatever. This is when it's in use, in RAM, actually being used, right? So being executed. So we're going to include, in fact, executing code as part of the data. So by performing computation in a trusted execution environment. And a trusted execution environment is what we're going to be talking about. CCA Realms are trusted execution environments. But there's more. It's got to be hardware-based. If we're going to have real protection, real isolation, it's got to be hardware-based. And the last word here is attested. And we're going to come back to that, but that's really important as well. So, confidential computing is protection of data in use by performing computation in a attested hardware-based environment, hardware-based trusted execution environment. And that is the definition by the Confidential Computing Consortium. That took 6 months to come up with. And adding attested took another 3 or 4, about 2 years later, okay? We're not a standards body, but we know standards body people. Okay, so what we're doing is basically we are protecting that workload. We are isolating it from all the other processes that are going on in that host. And I'd like to quote Charles from time to time. So here's a good one that I came across. I'm summarizing slightly, but the right to manage should not imply the right to access. So just because you're a host operating system and you're managing RAM doesn't mean you should necessarily access that RAM or the things that are executing in it. And so ARM CCA Realms provide trusted execution environments. And that's the first starting point that we want to think about. Got 11 minutes. It's going well. Next, this is really, really important. Attestation. So let's just go back one. Let's say I say to Grant, because Grant is trusted by everyone here. Nod, yeah, okay. So I say to Grant, please could you set me up a TE on your computer? And you say, absolutely. Excellent, great. So I say, I'm going to put wait a moment. The reason I'm asking him to set up a TE on his computer is because I don't trust him. Remember about not trusting people, right? And so how am I going to trust him to say he's set it up right? Okay, that doesn't work. It's like he's marking his own homework. So sorry, Grant, but I'm just not going to trust you, okay? So luckily, the clever people who work around TEs have come up with a way around this. So this is kind of the same picture we had. On the left, we've got, on the right, my left, your right, we've got a TE, okay? And that's the sort of big, bluey, purpley box thing around the thing. around what's going on. Inside that, we've got an application, which is the kind of the lower bit, and the data, which is the upper bit. Doesn't really matter, but that's just how I think of it. So we've got a CPU or a GPU or an NPU or some type of processing unit which is providing the TEE, right? And over here, we've got a user. Happy user, she doesn't know the pain she's in for. Okay, so what happens first? Let's say, and there are a number of ways of doing this. This is just one way. Let's say we've already put the application and the data in it. We ask, or it asks, the CPU, the GPU, to measure it. And by that, I mean take a cryptographic hash of the memory pages that make up what's in that TE. All good so far? Nod. It's Friday morning. Yes, good, okay, fine. And once it's done that, it signs that cryptographic measurement with a key which is embedded inside that CPU or GPU. And so we've now got a signed hash, basically, which is being sent to what's called an attestation service. The attestation service is the thing that checks to see whether that's been done right, okay? Because we want to check that that signature was created not by Grant, no, but by the chip that is on Grant's computer, okay? Because if that's the case, then we can have some trust in it, and that's a very, very good thing. So, assuming that the attestation service says, yeah, that looks good, maybe it also checks to see whether the hash is what is expected for that particular workload. That makes sense as well. It's one option. If that's good, we have a number of assurances now. The first assurance is that the TE is running on valid hardware because we've checked that signature, that the root key for that corresponds to a key the attestation service has checked before, has come from the manufacturer, for instance. We're also convinced, assured, that the TE is correctly set up, and that the things, thirdly, which are in the TE are what you expect. So that's kind of useful, right? We've got a bunch of really useful things we can work from here. So what does this allow me to do, having got this? Well, that's basically a certificate, isn't it? We've got a signed hash of some data using a key that we can check back to something else. That's a certificate. And we know how to use certificates. There's a whole bunch of really interesting things we can do them. So we can use it for transport. So we can say, if I'm talking to that TE or the software in the TE, we can know that we're talking in a fairly secure manner to it, and that what it is as well. We can prove identity and uniqueness with a certificate, and we could extend it. So we might say, okay, the stuff that's coming out of that application, because most applications produce something, right? They're maybe producing some data. We could sign that and say, okay, we know that what came out of that has come from that particular instance of that particular software. These are really useful primitives that we can start using. And that's on top of the confidentiality and integrity assurances that the TE provides in the first place, that no one can look in or can change what's in there. So we've got some useful stuff we can do here. Everyone nodding along still? Still awake? Yep, good. What does this give me? What can I do? Well, we've now got some useful and interesting security primitives. The first one the first couple are provided by the TEs. These are confidentiality and integrity. And on the right, the attestation also gives us uniqueness and identity, and assurances around the TE validity. Once you've got these, you've got a toolkit you can start thinking about how you use. And I want to spend a bit of time about how we might use that. Well, there are lots of obvious use cases which are around the confidentiality and integrity. There are lots of occasions when you want to run sensitive applications or applications that handle sensitive data on machines that you do not entirely trust, in places that you maybe do not entirely trust. So anytime you've got sensitive data in apps, there's all of these use cases that you can think of, and any sector you can think of will have one or more of these. I was once giving a birds of the feather presentation about this. Anyone could come along, and someone came along, and we were going around the room saying, what do you do, what's your thing? They were from a pest control company, a big pest control company in the States. And they really care about this because they've got lots of sensitive data that their customers don't want shared with their neighbors or other people, right, about the state of the pests they've got. So even pest controls. And I'm sure that every customer you have has some sensitive data in one of these use cases. And of course, these can be in the cloud, they can be internal threats, they can absolutely be on the edge as well. So pretty much anywhere we're deploying things, or automotive, whatever, as well. Space, we have some interesting space use cases as well. So that's great, but there are also some more complex use cases where things can get really, really interesting. Systems with multiple process stages where trust needs to be established or built over time. So let's say you've got some, you're training a model with some particular data, and then from there you get an inference engine. Well, you would love to be able to have provenance back all the way to the data, right? The initial data set. We can do that. Multiple stakeholders is another use case where this comes up, where you've got weak or non-existent trust relationships. Where you're trying to do financial collaboration around, I don't know, risk management or fraud prevention or detection. Pharma research is another good use. So the way I kind of think of it these days is you've got these different types of things. You've got multi-step processes or places you've got multiple stakeholders. So in AI, we've got sort of multi-step financial collaboration, pharma research, multiple stakeholders. But this is where I think things get interesting. When you're thinking about software supply chain, and we will be at 10:10 in this room again, please come along, you've got both of those, right? Same for hardware supply chain, same for Web3. And these are some of the use cases that we're really seeing beginning to pick up as people realize what you can do with TEs. And remind you, CCA Realms, absolutely, TEs allow you to do all of this stuff pretty much out of the box, rather than having to kind of build your own with the way you did with TrustZone. So I want very briefly to blow the trumpet for the Confidential Computing Consortium. We're basically part of the Linux Foundation, first and foremost, really important, and we work as a community to help people collaborate on these sorts of things, both on the technical side of the outreach and marketing, try and grow ecosystem and work regulator. Because we're part of the Linux Foundation, we care very much about open source, and we have, I think now, 14 different open source projects around confidential computing. And we kind of try to represent all different parts of the ecosystem, and all these different parts of the ecosystem care or should care about confidential computing. So I think my last slide is this one. I would love to speak to any of you about the Confidential Computing Consortium, confidentialcomputing.io. Very easy to find. It's even at the bottom there. These slides, I'm sure, will be available to people if they want to look at them. Whatever you're doing, whether it's ad tech, telco, healthcare, edge, Web3, anything, standard, boring old cloud, this is relevant to you. You need to know about Realms and how they fit into your ecosystem and how your customers are going to be using them. So thank you very much indeed.